In this video, we're going to go over how to translate a word problem into a linear inequality, and then I'm going to do a rough graph of it and talk about what that graph and the solutions represent. Let's rock and roll. So we are told that suppose your budget allows you to buy no more than $600 in video games. I stop reading right away because it says no more than 600. So that means that I have less than or equal to $600. I don't even know how that's going to work into this word problem. I just know that that is what that first sentence translates to mathematically. PC games, personal computer, cost $50 per game. So maybe I'll do, I don't know, 50x. So 50x. And I'm going to define some variables here. Let's define that x equals the number of PC games. So that would be $50 per PC game. Maybe it works into the inequality, maybe it doesn't. And console games cost $60 per game. So I'll do plus 60y, where y equals the number of console games. All right. Now, from there, we have an inequality. Let's see if it's correct. It says write an inequality to represent the situation. I'm going to make that a little more specific. Let's say write an inequality to represent the total combinations of different types of games, PC and console, that you can buy. That would be a little more particular in terms of the instructions. So the total amount of money we'd spend on the video games would be $50 for each PC game, plus the $60 per console games. So if we add up the total we spend on console plus the total that we spend on PC, that needs to be no more than less than or equal to 600. There's our inequality. So that's the key part, guys. That's your translation. We're done at that point. Some other problems will ask you to graph this, but the question is, what are we finding when we graph it? Other problems will ask you to figure out 3 or maybe 2 different combinations of video games that we could buy. We can do that one mentally. So I'm going to first start with that and then graph this, and then we'll call it a video. So if I look at this and I say, what are some of the combinations of numbers of PC and console games that I could buy? I'm just going to plug in numbers and see if they work with the inequality. So for instance, I could have 1, 2, which would be 1 PC game and 2 console games, just as an ordered pair. And if we plug that in, that would be 50 times 1, because that's x, plus 60 times 2, the number of console games. And when you do out this math, you get 50 plus 60 times 2 is 120. So 50 plus 120. And that is less than or equal to 600. So we can afford to buy 1 PC game and 2 console games. And you keep going like that. Let's pick, I don't know, x equals 0 and y equals 7. Let's see if we can buy 7 console games and no PC games. Well, that would be 50 times 0 plus 60 times 7. And we want to know, is it less than or equal to our budget of 600? Well, 50 times 0 is 0. 60 times 7 is 420, which is less than or equal to 600. So yes, we can afford that. If I put a 20 in here, we couldn't afford that because 20 times 60 is way greater than 600. So that's the algebraic reason why we come up with these inequalities. It actually allows us to calculate quantities of things. Now, how does a graph show this? Well, what I'm going to do is I'm going to graph this thing out without really discussing how to graph it out. To discuss how to graph out something like this, you would do that in an earlier video, right, in chapter 7. And that would be in 7.1 and 7.2, how to graph out those linear inequalities. So I'm just going to graph it out, and I'm going to discuss the meaning of that graph. So again, we have 50x plus 60y is less than or equal to 600. And I'm going to do this in a different way. I'm just going to do a rough graph and say, hey guys, this is the graph. So the graph is going to roughly look something like this. I know that I'm going to have a y-intercept at 10, and an x-intercept at, I'm going to need to move that way down, at 12. And I'll discuss why I know that in a second. And then I just need to connect the 2 points. And I'm going to shade below that line. And you might say, how did I get that? What I just did, and again, this is not about how to graph. This is about just interpreting the graph. I set y equal to 0 to find the x-intercept, and I got 12. I set x equal to 0 to find the y-intercept, and I got 10. That gives me 2 points, which gives me my boundary line. It's or equal to, it's solid. And I shaded below because that line is less than or equal to 600. So, quick way of doing it. Why is this important? Well, all the points that exist in this triangle here, including these y-intercept and x-intercepts respectively, they give you all the combinations of PC and console games we could buy. So for instance, the point 44, I don't know, it's somewhere around here. Without even plugging in these two numbers into x and y, we know that 44 is going to fall within this range. And so that means that I know I could buy 4 PC games and 4 console games. So graphs are actually pretty handy if you're trying to figure out, well, does this combination of numbers work or not? Pretty rad. All right, peeps, I'll see you in the next video where we'll learn how to translate into a system of linear inequalities from a word problem.